Welcome to Chapter 25. Today we're going to talk about the inspection and testing of welds. This is something, it's another thing, I say this all the time, it's another thing that a good knowledge of this will separate you from the average welder. Knowing the different types of inspection and what they're each good and bad at is really good information. And again, most welders don't know this stuff. Most welders are just welding. We want you to have a better knowledge than the average welder. That's why we go over this stuff. And for me also, inspection testing is really interesting. I really like being able to kind of do detective work on a weld, especially ones that go wrong. Like how did it fail? Why did it fail? I really enjoy that part of welding. So anyway, so why do we do inspection and testing? Well, inspection and testing verifies that work is being done to a specific level of quality or a specific code body. Even places that aren't working quote unquote to code, they still do inspection. You're meeting the standards of your employer. They're checking your welds, they look good, or they look the way they want them to look, whatever it is. So even places that don't do code work still do inspection. And when we get to inspection, it really breaks down two different types. Just had a moment. NDE, which is non-destructive examination. Non-destructive exam, and what I call DT. My mind is not working today. I'm putting the second letter first, which is destructive testing. So NDE, non-destructive examination, is the most common form of inspection we do in industry, and there's a ton of different ways to do it. The difference between these two is NDE, the product is still usable. I can do NDE on a part and I get to put that part out and sell it. Destructive testing, I destroy the part when I test it. So they don't do a lot of this in day-to-day industry. They do it a lot more for procedure qualification, proving something works, and then they do it very sporadically thereafter. NDE, they do it all the time, and you should be doing it all the time. So types of NDE, they've all got acronyms. Some of them make sense, some of them don't. VT, PT, MT, RT, UT, those are the big ones. Starting backwards, UT is ultrasonic testing, using sound waves to look inside of a weld. RT is radiographic testing, using x-rays to produce film, just like going to the dentist of a weld inside the weld to see if it's okay. MT is mag particle testing, using a magnetic field generator and using iron powder in our world to identify cracks at the surface and almost at a barely subsurface level. PT, which is penetrant testing, which is dye penetrant testing. They spray a dye on something, they wipe it off, they spray a developer on, the cracks show up or the holes show up. And then VT, which is visual testing. So out of all these, VT is the most common, visual inspection is the most common, and it's something you should be doing every day. Every weld you do, you should be doing visual examination on it before you throw it away, before you bring it to us, whatever. You should be doing visual inspection of every weld you do. Everybody should. The welder is really the first inspector on scene every time. You know, there shouldn't be a question as to whether a weld's good or not when you bring it to us or call the inspector over. You should know, well, yeah, this meets our standard or it doesn't. So visual inspection is key. It's the most common form of inspection in the industry. We've got a ton of really good videos online for all these processes. I'm not going to talk about it any more in depth here. You can find all that stuff online, but really good information. So destructive testing, the name is what it does. The one we see a lot of is when we do certification tests. We do side bends or face or root bends. Those are destructive tests. We're taking it apart, we're destroying it by cutting it up and bending it. They do other forms of destructive testing, but for us in the welding world, it's mostly bend tests. There are tests that measure impact toughness, like a sharp V-notch test. There's a video about that. That's another type of destructive test that's not a bend test. What's important to know is what these are all good at, because they're all really good at something. They're all not so good at something. So visual, the good, it's really fast, it's really easy. The bad is you can't see anything that is not on the surface, and you can't see anything if it's not well lit. So you should always have a flashlight with you to help you do visual inspections. Dye penetrant, it's really good at finding cracks on the surface, but it's only good at finding stuff open to the surface. It won't find anything subsurface. So cracks and porosity that are open to the surface, it works great for. Problem with it is it's messy. It's really messy. There's a lot of cleanup that has to be done after we've done the dye penetrant dressing before we can weld on stuff again. Mag particle, it's much cleaner than dye penetrant testing. It's much quicker usually. It's pretty much superior in every way, other than the fact that you can't do it anywhere. The upside of penetrant testing is you can take that little kit and go anywhere, and do it. Mag particle, you need electricity, but it's really good. And its downfall is it's only, at best, it is only good up to an 1/8 of an inch deep into the base metal. It really won't pick up anything much past an 1/8 of an inch, and honestly, an 1/8 of an inch is stretching. You're lucky you can find anything subsurface with mag particle. Radiographic testing, you're actually getting a picture of the weld, the inside of the weld. It's really, really good. The problem is it's really expensive. It's dangerous. You've got a guy on site with radioactive materials. Takes a lot of setup and planning to do radiographic testing. Ultrasonic testing, it's faster, easier, safer than radiographic, but it's a little messier. And up until lately, you didn't have a picture of the weld. That was what people always came back to radiographic for. Was you actually had pictures you could put in. You could put in your file and say, yeah, here's all the welds from this fuel tank. The Alaska pipeline. They've got every picture of every weld in the Alaska pipeline in a file somewhere. Up until very recently, you couldn't do that with ultrasound. It wouldn't take pictures. You would just scan it. And the operator is key to ultrasonic. You've got to have a really good operator to run it. So it makes it a little bit harder to do. So let's see. Let's talk about discontinuities versus defects. So these are two key terms that are very important. And knowing the difference will make your life easier. So there's discontinuities. And there's defects. So what is a discontinuity? So I actually wrote this down. I did not write this down. So a discontinuity is something that's irregular in the weld. It's a flaw in the weld, basically. Doesn't mean it's a failable defect, but it is something out of place in the weld. Every defect is a discontinuity, okay? But not all discontinuities are defects. There are some discontinuities that we have an allowable tolerance for. There is an allowance for porosity. There is an allowance for undercut. And there is an allowance, believe it or not, for slag inclusions. So all of these are discontinuities. If they exceed code standard, they turn into defects. So I've got undercut that's 3/32 of an inch deep. At a 16th, it's a discontinuity. Above a 16th, if I'm 3/32, it turns into a defect. So some things are always defects to AWS code. Cracks are always a defect. There is no allowance for cracks. Lack of fusion, also known as LOF. Lack of fusion, there is no tolerance for lack of fusion. It is a discontinuity that is always a defect. Arc strikes. There is no allowable arc strike. Every arc strike is a defect. So that's what you have to remember, is that some of these are allowed. Porosity, you can have a huge amount of porosity in an AWS plate test. It would freak you out how much porosity you can have in an AWS plate test and still pass code. It might not pass your employer standards, but it will pass code. And why I want to make this big distinction between discontinuities and defects is because you can spend a lot of money fixing stuff that's not actually wrong. And I've seen it happen. You get an inspector that, he's got his calibrated fingernail and he's checking your undercut with a fingernail. That doesn't work. I'm sorry, that doesn't work. Is it a defect or isn't it? If it's not a defect, if it's within code standards, if the boss is okay with it, I'm okay with it. ship it. That's my decision tree when it comes to building stuff in the shop. Will we get paid for this? Yes. Ship it. Let's build another one. So, like I said, the guy with the calibrated fingernail, he's not inspecting the code. He can't tell you whether that's a defect or discontinuity. Make him tell you it's a defect or discontinuity. We've got it. They make tools to measure undercut. You'll see them. We call them the green killers. There's an easy way to see if undercut is actually within spec or not. So, don't get hung up on stuff that's to code. I always like to produce stuff that's much better than code. Sometimes I can't. Sometimes it is what it is, and I get paid for it. So, anyway, what to do next? Watch the videos we've got for you. There's a lot of great information in these videos. They go a lot more in depth than I have on this stuff. And then do the rest of the coursework. So, that's all I've got. If you have any questions I can answer for you, let me know in the lab or online. And see you.